Good morning, everybody. So today's video is just how I drill the propellers to get them ready to put in the lathe. And when I filmed it and I didn't cut anything out, it took me about 20 minutes to get it all drilled and ready to go in the lathe. So at this point, it has just come out of the press, and I'm going to put the center pilot hole. I'm going to go ahead and drill that, and then I'll drill the end attachment points that I use to put it in the lathe with. This particular prop is going on a Lycoming engine, and most Lycoming engines have a 2 1/4 center pilot hole. That's very standard for that. They can have different bolt patterns, an SA1 or an SAE2 bolt pattern, and that's 4 3/8 or 4 3/4. But they generally, no matter what size the bolt pattern is, will have the same center pilot hole. And that's the same for a lot of engines. They'll have the same center pilot hole, even though they may have a bigger and smaller bolt pattern that goes with them. So the first thing that I do is I make sure that everything sets nice and flat and level, and then I bolt it down to the table. So that's what I'm doing here, making sure it's nice and flat and level. If there is anything underneath that hub, like a little wood shaving, if there's anything underneath it, that is going to give it a just even the tiniest little bit of angle and make the center pilot hole skewed just a little bit. And then when I go to drill my bolt pattern will be off. So it's one of the most important parts, and I'm actually drilling it so the side that is up and getting drilled is the side that will go to the engine. So I drill it engine side up. That's the way Grandpa taught me to do it. And my drill bit is squeaky, and I don't know why. It's the second one I've bought, and I don't know why they do that. But I have on my headphones, so it doesn't bother me much. But anyway, then I have to clean it all up. I make sure that I get, basically after every stage, I clean, I vacuum. That way I know that I don't have any of those little pieces that can get stuck underneath the hub. So I have drilled it almost all the way through, but not completely through. So then I will go ahead and unhook it so it's not going to be attached to, like locked down tight anymore. And I will put a board underneath it and drill it the rest of the way through. So I have maybe like a 1/16 of an inch to go through at this point. But I go ahead and leave the uprights in there because I don't have anything to keep that prop from spinning if the drill bit gets caught. So I leave those 2 uprights of that bolting setup in there so that if it tries to spin, it hits those bolts and won't come around and get me. Not that that's ever happened before. And like I said, I clean and vacuum and clean and vacuum after every part so that there's no wood chips really anywhere. And it helps to clean along the way, so at the end of the day you don't look back at the shop and it looks like a wood chip palm exploded. So there's my piece of lumber, and I like to go with a different color wood. So this is a maple prop, but I'm using a mahogany piece. So usually I can feel it. You can feel it when it breaks through. I can even feel the glue line. So whenever I am drilling, whenever it hits that glue line, there's a different sound and a different feel when you hit them. And I can usually feel when I break through the bottom, but if I have a different color wood, then when I see those wood chips, those darker wood chips coming out, then I know for sure that I have broken through. And there we go. Just like that, the center pilot hole is drilled. And the next part is I go ahead and take the router and put a little bevel around the center pilot hole. It makes it nice and clean and gives it a good look. Otherwise, sometimes whenever I'm sanding it on the, like on my sanding stand, the rod is, it has threads on it, so it's a threaded rod, and sometimes those threads will catch on that center pilot hole when I'm taking it on and off, and it'll tend to try to break some of the wood off of the prop if I don't bevel it now. Then it has a nice clean edge that doesn't catch, so that's great. So I go ahead and do that now, just so I don't have to go back and do it later. Okay, so now I'm going to take my 2 1/4 drill bit out and put my 1/4 inch drill bit in. That's what size the ends get drilled, is 1/4 inch. And I used to do this with a string, so I drill one end and then put a string and straight line it, because these 3 need to be in perfect alignment. That's what's going to give me my perfect vertical balance. If I get these out of whack a little bit, then I'm going to have problems with my vertical balance later. So my brother showed me the super neat way of doing it, a much better way of doing it, by turning that laser on, and then I can laser the line, and it's so much easier and so much more accurate. So I'll go ahead and put a bushing in the center pilot to help me be more accurate about where that center mark is, and then I will perfectly line up the 2 endpoints and that center pilot with that laser. And then, like, it has made such a difference whenever we do it with the laser. This is my first time doing it. Grant usually drills them for me, but I needed this one drilled today. So this is my first time doing it, but it has made every one that he has done has been so easy to vertically balance. And it used to be a big problem. It used to take me, maybe an hour, and it was really frustrating. So this has really been a game changer to do it this way. So super great. And there's my bushings that I'm putting in. And I'll use those bushings when I cut the prop too, because it's just a 1/4 inch bolt that goes through there. And I have to turn my light off or I can't see my laser. And it's just a little tap here and a little tap there, and it's very sensitive. You can just barely bump it and then you're off and you have to go back and do it again. So I'll use one end as an anchor point, and then try to match it up with, usually just match it up with the center, and then where the line falls on the other end I mark with a pencil, and then that's where I'll drill. And there we go, just right on the laser line, and then you just drill the 2 ends and you're ready to go. It's not a complicated process, it's just very tedious. So I don't like doing this part. I don't like drilling this, and I don't like drilling the bolt patterns because it has to be so precise and have so much precision, and it makes a huge difference. This is where you can ruin your propeller. Even though it seems like you'd have a better chance of ruining it on the bandsaw or doing something with the blades, actually the percentage of props that have a defect in them comes from drilling the bolt pattern or this right here, because if I don't get it right, the balance isn't right, and at some point you just have to call it quits on the balance and make it a reject prop, or someone gets it and goes to put it on and the bolts are just a little bit off, and so then that makes it non-airworthy. So this is the step where most errors do occur, and because it has to be so precise. I actually can't remember a time. Now, Karma's probably going to come get me for this, but I really can't remember a time that I have ruined a prop on the bandsaw, to be honest. And actually, I'm remaking this prop because the last prop was drilled just a tiny bit crooked and the bolt pattern was off. And we could have just, what they say, waller out the bolt and it would have been fine, because your propeller is not driven off the bolts. Your propeller is driven off the crushing power between your dry flange and your crush plate. That's what actually drives the propeller. So the bolts and the center pilot hole help you center it, but they're not actually what translates the power. So, but I don't like doing that. So it got sent to non-airworthy, and this is his new one. He's redoing his plane, so we have time to do this. So that was definitely the right decision. He had time, and it was the best fix. So that's what we're doing for him. And everyone's going to tell me that you should have something down there that holds it up for you. And I do, and it's a pain in the butt. So I don't use it because this is faster and easier. And some of the bigger props, like a 90-inch prop, I would have to have an extra something holding it for me at the end. But on this one right here, plus I can feel it with my arm. I can feel that it's nice and solid on the table. I can feel that it's nice and flat. And if you use that little table extender or whatever, then you can't feel it. And there's a difference between feeling it and looking at it. Sometimes it's not enough to, oh yeah, it looks level to me, or it's just not enough. So I like that, being able to feel that it's nice and flat and stable is just my way of doing it. And that's probably the way I will forever do it. It looks awkward, but it's not bad. Everything I do looks awkward, but it's okay. All right. So there we go. Ready, I'll take that drill bit out, put it back where it goes, and we're done, ready to go in the lathe. So I hope you guys enjoyed this kind of a detailed video about this part of the process, and I think that's all I got for today. So hope you guys have a good day, and I'll start working on the next video.